what branch prediction here? This is the key insight, message pack, type plus length, and then bytes, type plus length, and then bytes, control flow, one branch per value, deterministic pointer movement. So as you can see, we have one branch here per value, and it's a deterministic pointer movement. For JSON, like here, quote username, the control flow, branch per character, escape handling, code detection, Unicode logic, JSON equal many unpredictable branches, binary equal few predictable branches. So we have less misprediction because of this structure. As you can see, we have one branch per value, type plus length and bytes, and then type plus length and vibe, and deterministic pointer movement. And we have a code detection, Unicode logic, and then escape handling. This is exactly why binary formats are CPU friendly. What does skip blocks without branching mean? Example, A8, 75, 73, 65, 72, 4E, 61, 6D, 65. Decoder, first, reads A8. Second, knows length equals to 8. So once it reads that, A8, it will know the length that it's 8. So it skip blocks without branching, like without having to go through branching because it already knows the length. Then third, jumps forward the 8 bytes. So what makes it fast is the decoding. No need to check for the quotation mark. No need to check for forward slash. No need to check UTF-8 boundaries. This allows prefetch, vector loads, no speculation, disasters. So it allows you to prefetch it faster, or to prefetch. No, you don't need to vector load it because you don't need like to check all of those quotation forward slash and then the UTF-8 boundaries. No speculation, disasters because you didn't predict it. Is JSON heap allocation related to OS heap or stack? Yes, exactly that. So JSON parsing creates objects like open semi-curly bracket username colon quote Martin closing semi-curly bracket. Internally, this means allocate object on heap, allocate string on heap, allocate property table. So first you would allocate an object because this whole is an object, and then you would allocate a string because inside that object field is a string, Martin, and then you would allocate a property table and then store pointers between them. This uses process heap. So the process will use the process heap. What is heap allocated by the OS to your process or to your application? This entire thing or data of JSON will be stored on your heap via malloc or new or GC. It is managed by OS plus runtime. And it is managed by OS and runtime. So the OS and the memory on your PC or wherever you run your app, those two components will manage that. Binary formats in database often read directly into structs or mmap files or columnar buffers. Far fewer heap allocations. So you have fewer heap allocations in database than you would have in an OS or a normal server, because you have you read that directly into structs instead of like allocating an object or heap for it. So it read directly using mmap files, meaning you don't need to tap to malloc or something. It inherently support that, directly with the storage or columnar buffers for column storage. So how does this appear visually in memory? For JSON object, conceptual object, we have pointer to username and then another pointer to Martin. For message pack or columnar, so we have 8, and the next is username, and then 6, and then the Martin. So as you can see, it's like kind of like the type length, type plus length, and then the bytes, and then type plus length plus, and then the bytes. So the length is 6 for Martin, the length is 8 for username. Sequential bytes, no pointer chasing, because there's like a structure. You know exactly what those bytes next to it will do because it was provided by the previous line on it. So you get kind of like that temporal locality. So why are list structs? I mean, you get the temporal locality in your head instead of like pointing it onto another node on the system. So why are list structs arrays easy for CPU? Because they are contiguous, predictable, sequential. So as with the structs in a database, since those are binary formats such as UTF-8, those structs are contiguous, predictable, because they follow or they are encoded in a certain structure. So it came, for example, unstructured or not binary format. Once it get to the binary format, it became contiguous, predictable, and sequential. CPU strengths, you got the prefetch, cache lines, and SIMD. Pointers cause cache misses, cause stalls, break pipelines. How does relate to databases, Postgres, NoSQL? For row store, OLTP, so you have JSON-like access, pointer heavy, row by row. So we have two types of database, whether it's a row and column. For row, it could be relational or non-relational. It could be a JSON-like access for non-relational. Pointer heavy, so this could be since a B-tree or a PostgreSQL or any SQL relational database, they use pointer heavy. So that's how it relates, and they use row by row. You may think that a non-relational database use like not pointer heavy or like sequential, like a binary format, but yeah, they could be. But internally, their data structure, for example, for Postgre, it uses B-trees, but it store that storage in a binary format. Like it used a B-tree for its storage engine to like manage how it would be processed or return the request, but it used that a binary for storing it. For column store, it used a binary. So like in Postgres and Supabase, it's kind of different, but generally for relational OLTP database, they actually use pointer heavy row by row. It's not as efficient or access efficient as those in binary or as those in column store, which is an OLAP. So it use technically binary, length prefix, vectorized, scan friendly, same principles. Is this like Redux or React separation? Yes, but carefully. Layer browser. Responsibility tolerates malform input. Layer JSON. Responsibility human readable interchange. Layer Redux. Responsibility controlled mutation. Layer backend. Responsibility trusted domain logic. Layer DB. Responsibility strict binary storage. Databases win on security because they assume trusted input. They enforce schemas. They reject malformed data early. Browsers must accept garbage. What is JSON API? A JSON API is HTTP endpoint. So again, it's a type of HTTP. So you may think that JSON is just a data format. Yeah, it's a data format, but a JSON API that you would use to access those data is actually an HTTP endpoint. It's just part of an HTTP endpoint. So it sends or receives JSON text used between organizations, services, browsers. JSON exists because humans debug it. Tools inspect it. Schemas are optional. Databases don't store JSON internally unless required. So the reason why JSON exists is for human, not for database. Schemas are optional here, just like with Firestore. Tools can inspect it, but database don't store JSON unless required. So tie back to Redux, domain versus control state. Control state, Redux, actions, reducers, deterministic transitions, replayable, like CPU pipeline control, instruction, scheduling. So you have actions, reducers, deterministic transition, replayable for the control state. For a control state, when you compare that to a CPU, it's like a CPU pipeline control where you have each stage for the pipeline. It's like an structure scheduling. You would schedule that when it's complete. You're basically controlling the state. Even in React, you're controlling the state by having React control the state, how it would be executed, and the component can only schedule that, like the use state.